In this video, we're going to try to find the degree, the leading term, the leading coefficient, as well as the coefficient of some random term for a few different polynomials. And this will just give us some good practice finding these things for different polynomials. So we'll start with degree. The degree, if you'll recall, is the highest exponent that you have in any of your terms, the highest variable exponent that you have in any of your terms. So you look at all your variables, and I see I have an x to the first, I have an x to the second, and an x to the fifth. So the biggest exponent would be 5. So that's the degree of this polynomial. Now each of these terms can have a different degree, but the degree of the polynomial would of course be 5. Now the leading term is the term that has the variable with the highest degree. So again, it's this term that we're looking at here, and we typically write these guys in descending order with whatever their exponents are. So this negative 2x to the fifth would be listed first because it has the highest power. So this entire term, negative 2x to the fifth, would be what we call our leading term. Now a coefficient is a constant that's written in front of a variable. So this x has a coefficient of negative 3, the x squared has a coefficient of 7, and the x to the fifth has a coefficient of negative 2. So when we talk about our leading coefficient, we're talking about the coefficient of the leading term. So that would be this very first coefficient out here that goes again with the variable that has the highest exponent. So the leading coefficient is negative 2. Now just notice there though that when you're talking about coefficients, you don't actually include the x to the fifth. It's just the negative 2 that's the coefficient. And then lastly, the coefficient of just one of the random terms in the polynomial. How about the coefficient of x squared? So that would be the constant in front of x squared, so that would be 7. And again, it's just the 7, not 7x squared. So anyways, that wraps up this problem. Let's try a couple more. All right, we're going to start speeding up a little bit for the last few examples. This polynomial, if you look, really the only power variable exponent that I see is x cubed. So this is degree 3. The leading term, the term that goes with the variable with the highest exponent, would be negative 1.2 x to the third. That would make the leading coefficient just negative 1.2 only. That's just the coefficient. And it also happens to be the coefficient of x cubed, since that is our leading term. So that's the solution for this one. All right, the last two are getting a little trickier. This one here, we have x to the fourth over 4 minus 9x plus 17. You may not even really think of this as a polynomial. This first term looks a little strange. It's actually fine. We can actually think of this leading term here as 1/4 x raised to the fourth. Basically take that x to the fourth and pull it out of the numerator and just put it at the end and have it multiplied by 1/4. So that's how we could think of this leading term here. So that would be the highest exponent. It would be 4 for any of your variable terms. So we have a degree 4 polynomial. The leading term is that entire first term, x to the fourth over 4. All right, now what's the leading coefficient though? Well, it kind of looks like the number in front of the x to the fourth is a 1, but remember, if you pull this x to the fourth off the numerator and have it multiplied by a constant, actually the entire constant would be 1/4. So the 1/4 would be the leading coefficient of if you had x to the fourth over 4. And then the coefficient of the x would actually be negative 9. Not just a 9, you would include the negative as well. So there's that one. All right, we have one more to take a look at. All right, here we go. We have 2x minus 9x to the fifth plus 11x squared. Now one thing catches my eye right off the bat. These are not written in the typical order. We usually write these guys in what we call descending order, which means from the term that has the highest exponents on down to the lowest. So before we start talking about degrees or leading terms or coefficients or anything like that, we should rewrite this in descending order. So we have negative 9x to the fifth, that's the term that has the highest exponent, plus 11x squared plus 2x. All right, then it makes it pretty clear the degree is going to be 5. And honestly, even if we had not rewritten it, the degree would have still been 5 because that was the term that had the variable of highest power. Now the leading term would be the negative 9x to the fifth. And you might ask, well, Devin, what if we had not switched those terms around? Well, here, see, this polynomial is equivalent to this one. And so, we can't have different leading terms if they're the same polynomial. So we would actually technically still define this as the leading term because it's the term associated with the variable of highest power, but that would intuitively make the most sense if we wrote that term first, and that's why we call it a leading term. So anyways, the leading coefficient is negative 9, and the coefficient of the x squared, let me go find the x squared, that would be 11, and it's just the 11, not 11x squared. So anyways, hopefully that helps you better understand how to find the degree of a polynomial and the leading term and leading coefficient and the coefficient of any other term that you have in the polynomial.